Okay, so what we're looking at here is a depiction of the cardiac cycle, which is a way of piecing together all of the events that occur repeatedly as the heart continues contracting. You see up here in the top part, we have our ECG readout. Now, obviously the time frame is expanded. Those are much closer to each other in a real ECG reading, but all of the same information is there. Just below it here, we have the heart sounds. You see first and second heart sounds. This middle part right here represents pressures in three different areas. So this line right here is the pressure in the atrium. This blue line right there is the pressure in the ventricle. And this green line right here represents pressure in the main artery of the systemic circuit, which is the aorta. Down here in this part of the graph, we have the volume of blood throughout the course of the cardiac cycle in the ventricle, and the state of all the valves is shown down here. So let's see what this kind of graph can tell us. We'll start up here at the top with the first event on the ECG, which is the P wave. Now the P wave represents depolarization of the atria, and as we know, when an area of the heart depolarizes, the muscle contracts. When a chamber contracts, you should see a rise in pressure, which we do right there. The pressure in the atrium goes up as it contracts, and you see it labeled atrial systole. Remember, systole means contraction. The line for ventricular volume goes up at the same time because when the atria contract, it forces some blood into the ventricle below it. Now, the reason why the line for ventricular volume had been filling prior to that is because most of ventricular filling occurs passively. Only about 20% of the blood that moves from the atrium into the ventricle occurs because of atrial systole. During that time, our atrioventricular valves are open and the semilunar valves are closed. This is the first phase of the cardiac cycle called ventricular filling. Then up here, where we see the QRS complex in our ECG readout, begins the next phase, ventricular systole. Now there are two subphases to this, isovolumetric contraction and the ejection phase. Let's take a look here at our chart and piece it all together. So the QRS complex, that's depolarization of the ventricles, which, as we noted, when a chamber depolarizes, it contracts. So we see a couple things. First of all, the blue line, representing the pressure inside the ventricle, quickly goes above the purple line, which represents our pressure inside the atrium. When the pressure inside the ventricle is greater than the atrium, that forces our atrioventricular valves shut, closed. This dark strip that you see running vertically here, this is called the isovolumetric contraction phase. Isovolumetric means same volume. So even though it's contracting, the volume in the ventricle does not change during this brief period of time because during this time, all four valves are closed. Well, why are all four valves closed? The AV valve's closed because the pressure in the ventricle is now higher than in the atrium, but it has not yet climbed higher than in the aorta, so the semilunar valves haven't opened yet. The ventricle is essentially building up enough pressure to force open the semilunar valves. When it does, you'll see the blue line go higher than the green line, and that opens our semilunar valves. And this lighter colored strip there in the middle is the ejection phase. And as long as the blue line stays above the green line, the semilunar valves will be open and blood will be coming out of the heart through both ventricles. So we see over here the volume in the ventricle decreasing as blood is being forced out. Up near the top, you see these letters EDV. That stands for end diastolic volume. And that represents the amount of blood the ventricle begins with when it's maximally filled. And as we said, when the semilunar valves open, blood will be ejected, which is why our volume line is going down. It can only maintain that force for a brief period of time, and then the pressure inside the ventricle once again dips below that of the aorta, The semilunar valves close once again. The ejection phase is over. The third part of the cardiac cycle shown here is called isovolumetric relaxation. Just as before, all 4 valves are closed during this phase because the pressure in the ventricle is now less than in the aorta, but still greater than in the atrium. So all of the valves are closed at this point. You see down here ESV labeled, that stands for end systolic volume. And this is the amount of blood left in the heart when contraction is finished. Even an efficient heart will not pump out 100% of the blood that it begins with. So the difference between DV and ESV, you see labeled here as SV, that stands for stroke volume, or basically the amount of blood pumped out of the heart with one contraction. Now up here are our heart sounds. We haven't addressed those yet. The first heart sound, or S1, is made by the closure of the atrioventricular valves. Again, that happens when the blue line goes above the purple line, pressure in the ventricle exceeds that of the atrium, and that forces the AV valves closed, creating S1. During ejection phase, those semilunar valves will open, but when the pressure in the ventricle dips below that of the aorta, the semilunar valves close again, and the closure of those valve flaps slapping together creates the second heart sound, which is S2.